verified my product by gas chromatography and infrared spectroscopy.
The variable pitch propeller,
quantitative PCR.
Chainsaw, weed whacker, air compressor, electric toothbrush.
Petri dishes filled with agar.
Archimedes principle.
A microphone.
The back massager.
Fluorescent marker called cyber green.
A magnet with the north polarity.
Pipettes and plate readers.
Dog blood.
Force probe.
Modulus of rupture.
The negative geotexas assay.
Activated sludge.
A lot of the stuff you're working with you really can't see, so you have to use indirect methods to find it. I collected the data myself, mainly using pipettes and plate readers. What I was doing was measuring the amount of DNA that I had, and I did this with a procedure called qPCR, or quantitative PCR. And you do this by amplifying the amount of DNA you have. You add a fluorescent marker called cyber green, and by measuring how much the solution is glowing, you know how much DNA you have.
And then before I added bacteria, I took tests, and then after I added bacteria, I took tests to see how they changed over a 15-hour period. And then from this change, I could see whether the bacteria actually reduced estrogen or if it had no effect.
First, I tested different lengths of winglets and discovered that a 4-centimeter one was actually the most effective according to my scale. Then I used the 4-centimeter as a constant for the rest of my experiments, and I tested the height and the width as well of different winglets.
Finding the density through putting a material in liquid and making it suspend in liquid, it's really annoying process because it's on a scale the entire time, so the smallest amount of change, smallest amount of movement changes the results, so I had to do it over and over.
So like when an unexpected variable shows up, you don't necessarily stop your project, but you kind of formulate your project around it. For instance, your data might have an inconsistency. You take that into consideration, but you can kind of continue your project a little bit and see if this inconsistency keeps appearing.
Yes, it was a passed out survey. There was very little interaction with me and the participants. I wanted to keep this as anonymous as possible so that the subjects felt secure and felt comfortable answering these questions.
I was just sitting in my bedroom and I sat all the fish bowls together at times. I set aside certain times in the day and I just watched them and took notes and checked how aggressive they were towards each other and how much they ate.
My project was seeing if the temperature affected how the cricket songs changed. I had a microphone. It was really inexpensive. I think it was like $3, and I got it, and then I attached it to my computer, and then I recorded the cricket songs, and then I replayed them and counted the chirps.
What I did is I took the data by having an interrogation device that was generously loaned by a Medtronic defibrillator company and holding it over the device while it was being interfered or supposedly interfered with by my variables, which included, say, a chainsaw, weed whacker, air compressor, electric toothbrush, different electrical agents such as that. That information was then sent to a laptop computer and then printed out on a graph form. Had the interference caused the shock to be delivered, that's a potentially fatal error by the device.
I personally in the lab completed each reaction. I did the reduction, the dehydration, oxidation, and the rearrangement through a series of distillations and using all sorts of different lab equipment. I verified my product by gas chromatography and infrared spectroscopy.
As you see from the kids' reaction in their description, probably the most exciting part of a scientific project is collecting data. It means that all the work you've done to design the experiment, set up the apparatus, learn how to solve many practical problems has finally come to fruition. Of course, it's not a static thing. It's an active interaction. You keep learning that your whole approach was a bit imperfect here and there. You have to keep amending it. And that's part of the fun of the whole thing, that the students understand so well it's real science.